Okay, today we are talking about soil formation and we're going to touch on erosion. We're also going to be talking this week about the properties of soil. You guys are going to be doing your lab this week and looking at all of these characteristics of soil. So the objective for this unit is to describe the characteristics of soil and the formation of soil, and we're going to be looking at some of the characteristics as well as analyzing some data about how soil forms. So remember that soil is a mix of geologic and organic living living components. Sand, silt, and clay are the three size particles that we're going to be talking about, and you'll see those in our lab. Humus is the main organic part of soil. It's broken down living material, so biomass, leaves, sticks, dead animals, waste from animals, all of those are part of the humus. Nutrients come from the decomposing organisms as well as rock material breaking down and the waste of organisms. That includes things like ammonium, phosphates, and nitrates. Soil also has water and air in it as well as other living organisms. All of these are components of soil and they are essential for healthy soil to be fertile. Plants, water, those all play a role in soil quality. So soil is an anchor for the roots of plants and provides water and shelter and nutrients for growth of plants. Water is impacted because the soil is able to filter rainwater and runoff by trapping pollutants in those pore spaces. And certain plants are also going to trap and remove pollutants from soils as well. As the water filters through the soil, it actually cleans the water and as it percolates and enters into the groundwater and aquifers. It also recycles nutrients because of the decomposers that live in the soil. They are responsible for breaking down dead organic matter, which returns nutrients to the soil. And then it also provides a habitat for organisms like earthworms, fungi, bacteria, moles, and slugs. Those are all essential pieces of soil. And without those living things, the soil wouldn't be as healthy. Soil is formed through weathering. So weathering is the breakdown of rocks into smaller pieces. And there's three types of weathering. There's physical weathering, things like wind, rain, freezing and thawing of ice. Those are going to slowly break rock down. Biological weathering comes from the roots of trees or plants. Moss is actually a big one that leaches nutrients out of rock and then weakens them, allowing them to break. And then chemical is acid rain, and acids are also released from some plants like moss and lichens. Those all break rock into smaller pieces. The weathering of rocks is how soil forms. As rock weathers, it breaks into smaller and smaller pieces, and those are slowly carried away and deposited by erosion. Remember that erosion is the transport of weathered rock fragments by wind or rain, and it's carried to a new location and deposited. So when those fragments are picked up, that's the transport piece, and then the deposition piece is when those small pieces of rock are then deposited somewhere new. So soil forms from below, from the weathering of parent material. So smaller and smaller fragments are broken apart. That makes up the geological or the inorganic part of soil. So if you look here, this is your parent material. And as chemicals leach through the rock, as roots break down into the rock, that's going to break those rock into smaller pieces. Depending on the type of soil, it's going to break into smaller pieces, either sand, silt, or clay. And those are all particle sizes that we'll talk about. And then minerals are also being released there as well. Soil also forms from above because the organic matter that's falling adds humus to the top of the soil, and then erosion deposits new soil particles from other areas. You also have animals burrowing into that young or mature soil, plant roots also going down. Things that impact soil formation are the parent material. So the parent material impacts the pH of the soil and the nutrient content. So, for example, if you are soil formed that's mostly from a large shale deposit, that's going to impact the quality of that soil and the nutrients you find there, as compared to like a limestone type of rock. That's going to create a very calcium rich soil. So, depending on the type of parent material, that's going to impact the type of soil that forms. The topography, so whether or not it's on a steep slope, whether or not there's too much erosion, if it's too level, you're going to have high rates of deposition. So the topography is going to impact soil formation. The climate is also going to impact soil formation. The warmer the climate is, the faster the breakdown of organic material, which actually means that the soil is less healthy, because the faster that organic material breaks down, the less likely organisms and plants can use it. The more precipitation you see, there's more weathering, which means more erosion and more deposition. So that's going to impact how much soil can form in one place. And then living things, soil organisms like bacteria, fungi, worms, that impacts the speed at which matter can break down. When you look at soil, we have what we call horizons. So you have, starting at the very top, the O horizon. That's your organic matter. That's the humus, not hummus. You're not putting it on crackers. Humus, Humus. That's the layer of organic matter where you're going to see plant roots, dead leaves, animal waste. That's usually on the top of the soil. That provides nutrients and helps to reduce the amount of water that's lost to evaporation. The A horizon, or what we call the topsoil, is the mature humus. It's the completely decomposed organic material and the minerals from the parent material. So that top layer of organic matter, that's like immature humus. It's not broken down yet. The A horizon is the topsoil. That's your mature humus that's completely broken down. You've got minerals from the parent material that's coming up, and you have nutrients from the humus leaking or soaking down. The A horizon has the most biological activity with earthworms, soil microbes, and the breaking down of organic matter to release those nutrients. In some soils, you see an E horizon that occurs in this space, and that's called the zone of alluviation. The zone of alluviation is where you see nutrients sort of gathering and sort of holding. The B horizon, which is down here, that's the subsoil. It's a lighter layer below the topsoil, mostly minerals, not really any organic matter. There are some nutrients here, but this is like not really broken down yet. It's not very nutrient rich. And the C horizon is the least weathered soil. That's the closest to the parent material. Sometimes we call it bedrock as well. And then below that, which isn't on this diagram, is actually like solid rock that has that's the R. That's the parent material that hasn't been broken down at all. And former student came up with something to remember it, and he added the zone of alluviation. So it's obese, angry elves buy cookies. So if that helps you, feel free to use it. One thing we need to talk about when we talk about soil is soil degradation, which is the loss of the ability of soil to support plant growth. Soil degradation can happen in a few ways. The first one is nutrient depletion. That's the repeated growing of the same crops on the same soil. It's always going to remove the same nutrients. So nitrates, phosphates, potassium, sodium, magnesium. Over time, if you keep growing the same crops, you're going to keep removing the same nutrients. That reduces the ability to grow future crops, which means you're going to have to continually add fertilizers to help your crops grow. The next is loss of topsoil. That's usually due to tilling. That's the turning over of soil for agriculture. And the loss of vegetation. So if you don't have any cover crops, that's going to make erosion happen more easily. So wind and rain can easily carry away topsoil if there's nothing holding the soil in place. The loss of topsoil dries out any soil below it. It removes the nutrients, and the soil organisms that recycle nutrients are going to die. The last one is compaction. Compaction is the compression of soil by machines, things like tractors, bulldozers, the grazing of livestock, all of those that reduces its ability to hold moisture. Dry soil is then going to blow away more easily. It's going to support less plant growth. You're not going to have as many roots that can dig down in, which means you're going to have more erosion occurring on those soils that are compacted. Okay, so practice FRQ, put in your notebook, please. Design an investigation to measure the effect that climate has on soil formation. So how could you determine the impact of climate? Identify the independent variable, the dependent variable in your experiment. So just give a quick summary of what you would do and what you would change and what you would measure in your experiment. That's it for today, guys. Have a great night, and we will continue our soil extravaganza tomorrow. Okay, remember, you are allowed to be a masterpiece and a work in progress at the same time. Have a good night.